In this demo, I want to show you how you can use the async capabilities of bindings. Now, in most binding scenarios, as long as your data is already right there in memory, populated on whatever your model objects are that you're binding to, you won't have to worry about doing the binding itself async. You may have some code behind the scenes that gets these things loaded up asynchronously, but the binding itself won't have to be async. But depending on the way you structure things, you may have setters and getters on a given property that take a while to execute. So I'm going to simulate that in this case by putting a thread sleep in the get and set block of my phone property on my customer. And if I did that without doing anything else and try to run, first off, we can see as it starts up, it's waiting a full 5 seconds before the UI becomes responsive, because it's got to read that value in to populate the UI through the binding. And it's got to wait for that full execution of the get block to complete. Likewise, if we go and change that field and tab out of the field, you can see the cursor didn't move. It's gone completely unresponsive and will stay that way until the set block execution completes. And then it comes back to life. Obviously not the user experience you're going for. So if you're doing complex model objects that you're binding to, where the get and set blocks of the properties you're binding to execute real work, such as doing a database query or a service call or something, you may need to use async bindings then. So all you would do to leverage async bindings is go to the binding on the property that you want to be async and say is async equals true. Now if we start up our same exact scenario, you can see the UI comes up and is responsive right away, and then 5 seconds later the phone pops in there when the set block is finally done executing. And likewise, if we modify it and tab out of the field, it just goes blank and we can be using the rest of the UI until the point where the phone set block completes and the value pops back in there. So it just makes it a non-blocking thing. The WPF is going to actually go use a background thread to invoke the get and set blocks when you have is async equal true on the binding. But that also means that these are actually going to execute on a separate thread, so you do have to be concerned about concurrency if the UI thread can also access this code. The other thing to be aware of is that if you have multiple threads in your application and a background thread calls this set block, it's going to raise the property change notification, which goes up into the binding. The binding has subscribed to that based on seeing that your bound object supports iNotify property change. And generally, you don't want to be doing anything to a UI element on a background thread. The good news is in WPF, and only WPF, the other XAML technologies, this is not true. You can raise property change from a background thread, and the WPF binding will be smart enough to switch back over to the UI thread before it calls the get block and modifies the UI based on that property change notification. So it is safe from a binding perspective to set the property on a background thread. So another binding property related to async that you might use in some scenarios is the delay property. So I can add delay equals 500 on my data binding to my two text boxes down here. So I could add delay equals 500, and that's in milliseconds, on my two text boxes that are bound to each other down here. And what that's going to do is act as a throttle for input. So this only affects the calling of the set block. And it basically says my input may be coming quicker than I actually want to go set it on the data bound source object. So I'm going to delay by this much time before I call the set block. And if I would have triggered multiple times within that time window, I'm only going to call it once when that time window is up. So with that in place, we can see the visual impact of this behavior. If I go down here to my source, I start setting things there in sync. I go to my target and I rapidly input some stuff. 500 milliseconds later, it fills in the source. And it only set the source one time in that case at the 500 millisecond point. Do it again, and 500 milliseconds later, one set of the source happens, not one for each character that I was setting. So this is handy for situations like this if you may have some very rapid input, especially if you're doing something like an autocomplete service call to look up the available candidates, and you don't want to do that service call on every single keystroke. Another example would be if you were binding the current position in something like a slider. You don't want to necessarily go set the property on the source object on every minuscule movement of that slider, just when it finally settles in position or has moved by a significant amount. So you could set the delay property on there so that it only sets the source property every 500 milliseconds, for example.